Hello everyone, I'm Raza Kayani. In today's lesson, I'm going to talk about effects of forces, balanced and unbalanced forces. You are watching revision series of high school physics. At the end of the lesson, I'm going to explain and solve some interesting exam questions related to the forces. By the end of the lesson, you should be able to recognize that a force may produce a change in size and shape of a body. You will be able to describe the ways in which a force may change the motion of a body. Describe what is meant by the resultant force. You will be able to calculate the resultant force of two or more forces acting on an object. By focusing above learning objectives, you should be able to solve your exam easily. Here is the list of the sum of keywords used in the lesson. These keywords will give you confidence to link the unknown terms with the known. The known terms in the list will help the students to boost the learning process. A push or pull that tends to accelerate an object is called a force. Force is a vector quantity because it has direction. The unit of the force is newtons. Now I'm going to talk about what are the effects of forces. A force acting on an object causes the object to change its shape or size. It causes the object to start moving from rest. It helps to stop moving objects. A force causes to accelerate or decelerates the object in different situations. Forces can change the shape, size, motion, and direction of the objects, but they cannot change the mass of the objects. The mass of the object stays the constant. By kicking a football, its speed can be increased or decreased. A hockey stick is used to increase or decrease the speed of a ball during the game. Forces can change the direction. Forces can change the direction of the movement of an object. The direction of the ball can be changed by bouncing it on the wall. In cricket, a bat is used to change the direction of the ball by applying a force. Forces can change the size or shape. When forces are applied to a solid objects, they can change their shape or size. A rubber band gets longer on applying force. An empty can change its shape on applying force on it. A sponge can be squeezed easily. Forces can change motion of the object. Forces can stop moving objects. Forces can move the stationary object. If you look at this example, if the object is stationary, so the resultant force acting on the object is zero because none of the force is acting. The weight of the car, W, is balanced by the reaction forces acting from the wheel upwards. So the resultant force acting on the car is zero, it's not moving. If the same car starts accelerating, that means the force of the engine is greater than force of friction backward. So the car is accelerating. The size of the arrow shows the magnitude of the force. So the forward force is more. So in this case, the car is accelerating. If we look at the second example, forces can stop moving object. If the same car is moving with constant speed of 20 meters per second, the forces acting on it are balanced forces in this case. So as soon as the driver is going to apply the brakes, so what will happen, the backward force is going to be more than the forward force. So in that case, the car is going to decelerate. The bigger line shows the greater magnitude of the force acting backward as compared to the forward force. Now we can practice one question. A car travels forward along a straight horizontal road. Only the horizontal forces acting on it are shown. So here we have a force, driving force forward, and air resistance and force of friction, they are acting backward. Now here we have a larger arrow that shows the greater magnitude of the force, and the small arrow represents the driving force is less in that case. So the question is, the length of each arrow represents the size of each force. How do these forces affect the motion of the car? There are 4 options. The car moves at constant speed, the car moves backwards, the car slows down, the car's forward speed increases. Okay, now we are going to see one by one. Now we are going to see each option. The car moves at constant speed. That's wrong, because both forces are not balanced, so it cannot move with constant speed. The car moves backward. The car actually cannot go backward. B, the car moves backward. In reality, car cannot move backward. So this is also wrong. The car slows down. That is the option when forward force is less than backward forces. So in that case, there are chances for the car to slow down only. So the answer in this case is C. To understand the change in shape and size, extension and compression are the good examples. When the forces are applied as a tension on both ends of an object, they cause the object to stretch, and extension is occurred. If the force is doubled, extension doubles. If the force is triple, the extension triples. If this material is stretchable, and if we are going to apply equal amount of the force on both sides, these forces are going to stretch the length of the material. After applying the force, the shape will look like this one. So there will be a tension. The forces acting on both sides can extend the object. So the length of the object increases by applying the force. When 2 or more forces are applied as a compression, they cause the object to get shorter. A compression can be observed. If this is the original length of the material, and if we are going to compress from both ends, and if the material is compressible, so the size is going to change. That is the real size of the object, and now the size of the object is going to reduce, and it's going to be fatter from the middle due to compression. Balance forces. Here are some examples of the balance forces. Hanging objects, floating in water due to upthrust, standing on the ground. In tug of war, if the people on each side of the rope are pulling with the same strength, but in opposite direction, the forces are balanced. None of the team will be winning in that case. If 2 equal forces are applied to an object in opposite direction, the object does not move. If you look at this diagram, if we apply equal amount of the force on that toy car, for example, if 50 newtons from the right side and 50 newtons from the right side and 50 newtons from the left side, the car is not going to move because the forces are balanced. So in that case, the acceleration of the car is 0 in that case. Now look at the second example. If this car is moving with constant speed of 2 meters per second squared, now resultant force 7 newtons minus 7 newtons, that's equal to 0 newton. So the sum of the forces is 0. So acceleration acting on that car is also 0. So these forces are also balanced in that case. When 2 or more than 2 forces are acting on the body, causing no resultant force, we say that forces are balanced. When an object is moving with 0 acceleration, different forces acting on it are balanced. In this situation, the net force acting on it is 0. If we look at this example, the thrust of the engine of the car, if that is 20,000 newtons, and if the air resistance acting backward is also 20,000 newtons, so in that case, the net force in that case is going to be 0. and acceleration of the car is going to be 0, so the forces are balanced. Unbalanced forces. If resultant force is acting on an object, it will accelerate. When a car starts moving, the thrust from the engine is much greater than the air resistance. The car accelerates. The faster the car moves, the greater air resistance acts in opposite direction. In this case, the forces are not balanced. For example, the thrust of the engine in this case, if that is 20,000 newtons and the air resistance acting over here is only 10,000 newtons. So the air resistance acting on the car is 10,000 newtons. So the forces are unbalanced. So the car is accelerating. In that case, acceleration is not equal to 0. Unbalanced forces cause a change in the motion. As the car goes faster, the air resistance increases until it is as big as the maximum thrust from the engine. The car is now moving with constant speed in a straight line. The resultant force acting on the car is 0. If you look at the amount of the forces acting on this car, if the forward force acting on this car, that is 30 kilonewtons, and the backward force acting on that car is only 20 kilonewtons, so that car is accelerating. But after some time, if the forward force is 30 kilonewtons and the backward force is also 30 kilonewtons, in that case, the resultant force acting on the car is 0. Now I'm going to talk about resultant force. What is a resultant force? The resultant force on object is the force left after equal and opposite forces are cancelled out. The one force that would have same effect as all of the forces. It is the vector sum of the forces on the object because force is a vector quantity. Two or more forces acting on an object can be added or subtracted into a single force is known as resultant force. In this case, the forward force is 3 newtons and 2 newtons acting on an object. So we can add up both. So sum of the both forces is going to be 5 newtons to the right. And that force is a resultant force, or we can say that's a net force. In the second example, the force acting to the right is 3 newtons and force acting to the left is 2 newtons. So the resultant force in this case, that is only 1 newton. In the following figure, the resultant force is acting to the left because the force acting to the right is 2 newtons and the force acting to the left is 5 newtons. So 5 minus 2 is 3 newtons force acting to the left. So resultant force in this case is 3 newtons to the left. In the following figure, the forces of friction due to surface of the ground is 10 newtons. So resultant force of 40 newton is acting to the right. So in this case, I'm not going to talk about air resistance. There is a 10 newton is the force of friction. And 50 newton is applied force. So in that case, resultant force, 50 newtons minus 10 newtons, that's going to be 40 newtons to the right. Now we are going to practice some questions. The diagram shows an object being acted upon by 2 forces. So the force acting to the right is 6 newtons and the force acting to the left is 3 newtons. That force might be switched that way. You know, there is a way to write also this way. Okay, this force 6 newtons to the right, and I can apply 3 newtons here to the left this way. So what is the size of the resultant force on the object? Simple, what can we do? First of all, we choose the force acting on the right, that is 6 newton, and then the force acting to the left, that is 3 newtons. So the resultant force is going to be 3 newtons to the right. So the answer in this case is B. There are 2 forces that are applied on a block, 7 newton to the right and 4 newtons to the left. Calculate the resultant force in this case. So the 7 newtons to the right and 4 newtons to the left. So the resultant force is denoted by F, 7 newtons minus 4 newtons, and that's going to be 3 newtons to the right. If they ask you to show with the help of the diagram, you can draw this kind of the diagram. Now we are going to practice another question. A train is traveling along a horizontal track at a constant speed. Two of the forces acting on the train are shown in the diagram. So when they say it's moving with the constant speed, that means the acceleration acting on the object is 0, so the forces should be balanced in this case. A force of air resistance is also acting on the train to give it resultant force of 0. What is the air resistance force? So we have to calculate the air resistance force. So the force from the engine, that is 60,000 newtons, and the force of friction that is acting, that is 20,000 newtons. So we can calculate air resistance by writing 60,000 newtons and subtracting 20,000 newtons, and that's going to be 40,000 newtons. That force is acting to the left. A car moves along a level road. The diagram shows all of the horizontal forces acting on the car. Which statement is correct? Now, we have to look at the forces. The force from the engine is 2,000 newtons, and air resistance is 800 newtons. And the force of friction, that is 500 newtons. So we can add up these forces, 800 newtons and 500 newtons. So sum of these two forces is 1,300 newtons. Now we can subtract. So the total force acting forward is 2,000, and the total force acting backward is 1,300. So in that case, the resultant force, in that case, the air resistance acting, we can calculate the resultant force acting on the car. F equals 2,000 newtons minus 1,300 newtons, and the resultant force will be only 700 newtons to the right. That means the forces are unbalanced. And now we are going to see the option. The car is slowing down. The car is speeding up. The car is moving at a constant speed. The car is moving backwards. So in that case, if you look at the first option, the car is slowing down. No, that's not the case, because there is a resultant force and the car is speeding up. The car is speeding up. That is the correct answer. C, the car is moving at a constant speed. No, the forces are unbalanced, so that is not the option. The car is moving backward. That is not possible even. So our answer is B in this case. Now we can practice another question. 4 objects are each acted on by 2 forces as shown. Which object is in equilibrium? So we are going to see the forces in equilibrium. 2 newtons downward, 1 newton upward. So resultant force is 1 newton downward. That is not in equilibrium. Here, 2 newtons upward, 2 newtons downward. So 2 minus 2. So resultant is going to be 0. That could be in equilibrium. So 3 newtons upward, 2 newtons downward. So resultant force is 1 newtons. So that is not in equilibrium at all. Now, here, 4 newtons upward, 4 newtons downward. So the resultant could be 0, but that's not the possibility. I'm not going to write 0. Look, here, B and D, the forces are equal. The problem is whenever we want to decide the balance forces, we have to see the same line of action. So only B has the same line of action. In that case, the answer is B, where the object is in equilibrium. It is not accelerating. It has a balanced forces, because in D, the line of action is different. So that object might rotate. So we are not going to choose D. So whenever we are going to decide balanced forces or equilibrium, we have to see the same line of action. A boy of mass 60 kg has a weight of 600 newtons. This 600 newtons will act downwards on the table, and the table will exert a 600 Newton force upward on the boy. What would happen if the upward force were less than 600 newtons? So the weight here acting 600 newtons. If the reaction force of the table, if it cannot apply the force equal to 600 newtons, so there is a possibility the table might collapse, okay? So it might break from the middle. So that's the reason when the forces are not balanced. So if the table cannot apply the same amount of the force upward, if the normal contact force is less than 600 Newton, the table might collapse. So they will be unbalanced forces in that case. Thank you for watching. Subscribe to the channel to receive the next lesson.